And in this talk we talk about diaspora and why we choose this as solution of some more problem. In Pisa we have a mesh network, and we encounter some problem that bandwidth exhaustion. To solve this, we choose to look at what is traffic going on our mesh network, and we discover that the half is peer-to-peer and half is Facebook trash. So we first solved it with peer-to-peer, then cut peer-to-peer, but the day after, someone magic go with a solution, and we found this on our network. Bitarno, that someone put up a server, a peer-to-peer server on our network. Then this solves part of the problem, but the problem is that we discovered that the server is situated in a place on the network, and the last hop link is acting as bottleneck. That we solved it with internet bandwidth, because there is no peer-to-peer traffic on going out of network. But when the user go to download from server, they are going slow because there is a lot of traffic in the last hop. So when we go to solve the problem with social network, we think that we have to find a distributed solution. So we looked for what open source offer, and we found the best at the moment to distribute on social network is diaspora.
Okay.
No, the map server from Linux. So. Diaspora is a distributed social network, but how it works? Then you set up what is called a pod, that is simply a web server with a DB, and not only you, but a lot of people set up a pod, and you register yourself in a friend's pod, someone you trust. So your data is remaining on a local server or on your or of some friend. Then you don't have to ask yourself, oh, what they are doing with my data, because you have your data, or at max some next to you. People with other friends register on another pod, and pod talk to each other. And you can find people from other pods. It works in this way. This is your pod in Pisa.
What's the password?
I have a lot of friends, so not all is from my pod. My pod is diaspora.igalamp.org. You can see I have a friend from other pods, like Closhy. He's using diaspora too, and he is registered to another pod that is another place on the network. So when I look for Closhy, automatically the pod look for Closhy pod, and I find him. Do you remember something?
Yeah. So we appreciate this the diaspora, but we think that we could improve it. And so we, first of all, we noticed that there isn't any way to chat with other people on the network. So we are implementing an XMPP server, a Jabber server, to create a chat, and with the Jingle extension also to integrate the video and audio chat. And maybe you
okay.
about
something I missed from diaspora architecture. diaspora architecture is strongly based on relationship you have with people. So you can see here something we call aspects. I have hackers and there, sconosciuti, that is unknown people that add me. I classify as this kind of aspects. Work, family, and when you publish something, you can select who can see this, but in a very intuitive way. I show you. Then I want to publish a post with hackers and dev and work people. Okay.
It provides also an integration with Twitter and Facebook, so we can choose to publish something also with a special aspect, which is word. So
Yeah.
there, and so your posts are visible also from outside if you want it. Yeah. Okay.
Okay.
The exchange of the messages between the user is a project. So how it works? When you create a post message like this, a random key is generated, and the message is encrypted with this random key. And the message encrypted is sent to the recipients. But how they can decrypt it? This random key is also encrypted with a public key of the recipient, and this message is sent to the recipient too, so he can decrypt the header and check if the sender is the one he claimed to be.
So you can see that what I publish on my diaspora profile, thanks to Facebook integration, I set that it's public. Then you can see it also on my Facebook profile. And there is another improvement I am planning to do. At the moment, diaspora depends on DNS systems. This is a problem because DNS system is centralized and require management. So I'm looking for a way to do pod auto discovery without depending on DNS. And suggestion I will come because I do not do nothing at the moment. I was thinking about MDNS, but there is some limitation due to multicast and local network, and you can deploy it on internet at the moment. So suggestions are open.
Yeah, that's all.
That's all.
Question?
Yeah.
Did you push these changes back to the diaspora release? So most likely all diaspora releases will...
Yes, we are already in contact with the main development team. They are very happy of our modification on software and are helping us to do diaspora better software.
Great.
Thanks.
This is the first thing we want to do at fork. We want to collaborate with others, because we think this is the better way to improve our software. Ah, okay. Okay.
It's on the website.
Yes.
Can you go?
Yeah, detach and no.
Use Firefox?
Yeah. Okay, it's for it.
It slipped inside.
Do you need this?
You want to put it up here?
It's connected to the Wi-Fi? What? I don't know. Okay, go.
Okay,
How do you do? Okay, I go. There is no answer? It's okay.
We have it?
How is it slow? Is there a microphone? Okay, I just wanted to quickly show you what we did at the previous battle mesh. You can't hear anything? The previous battle mesh we organized in Charleroi in Belgium. So basically, we ran the same script that was running in Bracciano, but with the particularity that we tried the dual channel approach with two cameras connected with an Ethernet cable in between. And you have there the schema of the network setup we made over there, where we connected a house and a horse building together on end-to-end, and we managed to get 350 kilobyte second stable end-to-end. So this is a picture of a second node that we set up 50 meters further from the first house, and this was powered over Power Ethernet with the ITX power supply I have made with two cameras on two channels. And over there we run BMX, OLSR, and Babel. And we saw, by comparing the three, that, for example, BMX was more reactive, but that was probably due to the fact that Axel was there to tune a bit the parameters. But we saw that Babel was more reactive, but BMX was more reactive. So we had a third node, which was a car where we put it, I can zoom, where we installed two phoneras on the roof. Over there, and so we had connected that to the battery of the car, and we were able to debug by moving the car to adjust the length and so on to see when we go losing connection and see how it behaves. So unfortunately, it was on next to some fields, and at some point our car got stuck into the field, and we spent at least 1 hour debugging this problem by pushing. And at some point the road was like that. The car was, totally perpendicular to the road, and Peter and Axel, we spent a lot of time and energy trying to get our car back on the road. And at some point I was driving it, and my driving knowledge is not very extensive, so it took me at least a second to find where was the brake. And on the back there was a big pole, a concrete pole, and I was at 5 centimeters to make the damage to the car. So this caused I can see it wants to go back. Yeah. So it caused our friend Peter to lose his shoes for the rest of the battle mesh. And so you can see here that the shoes were totally full of mud and so wet. So at the end of the battle mesh, he was walking with naked feet until process. So what we learned from this edition was that the power is critical if you want to play with distance, and that the dual channel approach worked quite well. And I hope that we will have the time to reproduce it tomorrow with the new Bubble Z version that we will produce. And yeah, so in the future I hope that I will be able to set up a permanent test bed with multiple channel devices, that it's better, it's easier for developers to improve or to debug network problems that comes with the fact that you are using multiple components. You have a question?
That was minus Z2, that's not right?
Yes. So that's it. Thanks. Maybe.
Put it on the table. I told me. You? You are skipping the next second time now. How are you running? It was my mistake. Right. You have something against I give you a beer. Drink beer for me. You got so many talks. Let others speak. I agree. I don't know why. Next time we have one total agenda just with you. One talk after the other. Okay?
Hi. I'm Andrew. I did not intend to give any presentations when I arrived here, but it turns out that lots of people have questions about BGP. So I've thrown together a quick little presentation, hopefully can answer some questions or provide some more information as to what it's all about. So some basic information, it's standing for Border Gateway Protocol. Currently is version 4, and if anybody cares to read the RFC, it is 4271. The previous versions are quite outdated now. They don't even support CIDR, so I would hope that that means that they are not even being used anywhere, but anything is possible. It uses TCP, port 179, to communicate with the neighbors. And at the bottom I have that the neighbors must be configured manually, so it's very much not like any of the wireless mesh protocols or SPF or anything like that where the nodes find themselves. All of the nodes need to be configured explicitly. The primary goal is to exchange routing information in the form of prefixes between different networks. They're called autonomous systems. Each autonomous system has a network, an AS number, which is the primary identifier for that ASN. And because the intention of BGP is to sort of say, where is this network? How do I get it there? It's not concerned in any way with the internal topology of these networks. So as such, it just says, how can I get it from A to B? I will get it via C, and off you go. Once it gets there, let him sort it out however he likes. So that's good because you want to keep it as simple as possible so that you can scale it higher to the level of the internet. But at the same time, since it's so ignorant of what is going on, It can choose the best path, might be the most congested, and it is completely and utterly ignorant of that. But again, that's why we have internal protocols such as OSPF, ISIS, or even OLSR. I don't see why not. Let those protocols deal with that, and BGP is more the overview to the world. The primary goal is for multi-homing. So you will get different routes coming in from different places, and you bring all of these into your routing table and you analyze what's the best path to get here, what's the best path to get there, and you can make choices based on that. If you are not multi-homed, there are very few reasons why you might want to run BGP, because all routes will have the same path, and so why not just use the default route? There are probably a couple of cases where you might want to do this, but for the most part, not especially useful. It's very, very good at giving you policies where you can say, I have all of these routes coming in from all of these different places, which one will I choose? It's extremely flexible for choosing routes and controlling how you will send the traffic, but unfortunately it is almost useless for controlling how the traffic will come into you. There are some things that you can do, but at the end of the day, you do not control the other side of the link, and that network will send the traffic to you however they like, and you just have to be able to deal with that. There's a couple of things you can do, such as you can prepending, which is to artificially raise the length of the AS path, which is something I'll get to in a bit. Or you can deaggregate, which means that if you have, let's say, a /20 assignment, and you have, 124 in Paris, 124 in London, 124, somewhere else, you could send the entire /20, and then you could also, on top of that, send a /24 route only in this location, because as route selection works, it will take the longest path that exists. So you can control it in some ways, but for the most part, you cannot control the other person's network, and so that's that. So autonomous systems. Any BGP speaking router must belong to one and only one AS number. They're 2-byte values primarily, so any number from 0 to 65,535 is a valid AS number. They're assigned by the regional registries such as ARIN, RIPE, APNIC, the like of them, and they're registered similarly to how IP address assignments are registered. Very recently, 4-byte ASN support has been introduced. I think for the past couple of, maybe 2-3 years ago this was done. And thankfully, they managed to find a way where it is actually backwards compatible. So this is able to be used already today. It's in use. And even if you have an old implementation of BGP4, which does not understand 4-byte ASNs, it's been done in such a way that this continues to work. So unlike IPv4 and IPv6, having to do a whole bunch of work and generally not taking place at the speed which some people would prefer, thankfully this is actually backwards compatible. I'm going to skip over the details of precisely how, but anybody can feel free to read about that if they like. So all of the routing table entries are in the form of prefixes, which is probably not dissimilar to other protocols. So for instance, 109.69.8.0/23 is the IPv4 prefix for GUI-FNet, or there's 2001:470.32, which is Hurricane Electric. They're a large IPv6, IPv4 transit network provider. Currently on the internet today, there are approximately 335,000 prefixes, IPv4 prefixes in the global table, and approximately 4,500 IPv6 prefixes. And in total, that's being announced by approximately 37,000 ASNs. And so you can see if we're using 37,000 ASNs publicly, and there are only 65-some thousand available, you can see quite clearly the need for 4-byte ASNs. So I mentioned previously AS paths. This is not the only way that BGP determines how to send the information around, but it's typically the primary method for making this choice. There are many other metrics as well, but for now we can focus on this because it's one of the most important parts. So again, example, WBMv4 has their IPv4 prefix, and they announce it from this ASN. They announce it to their upstream providers. They add that route into their information. The upstream provider adds their their ASN into the path and propagate it on to their peers again and again and so on until it's reached the entire internet. And so you get an example of an AS path perhaps looking something like this. This is from a router in London. Show me the path to WBMv4, and it goes through 3356, which is level 3. Level 3 then sends it to 174, which is Cogent, who then in turn sends it to WBMv4 router. From there, it's just internal, which is the little I. So we have a simple internet. I've stolen this image from my product's website, but you can see here router 2 is belonging to AS200, router 1 is an AS100, router 3 is an AS300. And for the purposes of just a very small example, there's one prefix here, 192.168.0.0/24, and another one here. So these routers here, and this is an internal BGP session, and then because it's within the same AS, and I'm going to just skip over that little detail because this is not meant to be an exhaustive view. So this router here says I have this network. He sends it over to router 3 within the same AS number, and he says, okay, I know I can get to this. Now this router announces to his peers this way and this way, I have this network here, 192.168.100, so this router says, okay, for this prefix, I must go via AS300. And how do I get to AS300 is via this session here. And similarly, the route is propagated this way, and so R2 knows that you can get to this prefix via its link with R3. What also happens is this prefix gets sent up here to router 1, which in turn sends it back into router 2. However, so now to get to this prefix, router 2 actually has 2 possible paths. But because this has the shortest AS path, in most cases, this is the way it will go. Of course, you're free to route traffic however you like. They may have a policy that says, well, actually, this link here is less expensive. They're giving you this link for free. This is a very expensive link, so the traffic may come in this way, but I would prefer to send it that way. And so even though this is the longer path, perhaps...
How do you deal with loops?
Sorry?
How do you deal with loops?
How do you... Well, this...
Like if policy-induced loops.
Well, hopefully your policy does not dictate such things, but it's possible that you could send it this way, and it's also possible then that router 1 has a policy on it, on a link which we do not see here, sorry, it may loop, but hopefully that will not happen. There are... Sorry?
It already happened.
Well, it does indeed, yeah, but it's rather suboptimal.
It's not the global.
Yeah, but if you have no control beyond your own autonomous system.
That's why there is field TTL.
Basically, yeah. If you have created a routing loop, then you are going to have to shut down and somehow maybe send it over this other link instead. But again, you have no control over that other ASN. Sorry. Hopefully that does not happen, but it does quite frequently, in fact. One really, really big problem with BGP and the internet is that it is effectively a trust-based system. I have a peering with your router, you send me all the routes you know about, and I just accept them into my table, and I propagate them on to my peers as a good router should. Unfortunately, a side effect of this, there's quite possible that you can simply declare, I have this network here, and it will, off it goes. And so there's a couple of noteworthy examples of this having happened in 2008. The Pakistani government wished to censor YouTube, and they didn't quite do it properly. Well, they did, perhaps. Instead of just blocking it within Pakistan, somehow this route leaked out to the internet at large, and all of a sudden now all of the traffic all of the routers on the internet are saying, okay, I wish to get to YouTube. Aha, here it is over here, and off it goes to Pakistan. And that caused, obviously, a bit of trouble. And more recently, China Telecom, again, somehow, some misconfiguration, some nasty things. I'm not sure if we actually know precisely what it was, but some 37,000 prefixes, they declared, oh, bring them over here. And that caused also some problems.
There is a theory that it's well connected to filtering.
Yeah, there are many theories, but it could be all sorts of things. Some people think it was malicious. They're trying to intercept as a sort of a man-in-the-middle type of thing. It could just have been an innocent accident. The jury's still out, I believe. We probably will not find out. So they've implemented routing registries such as RADB, and there are many, many of these. The goal of the routing registry is to say for this prefix belongs to this ASN and any other claims are bogus. They also have provisions for saying this is my network and these are my peers, the people to which I announce routes, and if you see anything else that is bogus. There are a couple of issues with this. It's not widely implemented yet. Many carriers, I believe level 3 is definitely doing this. You have to create rather complicated prefix lists. Or prefix filters in your routers. You can imagine with 350-some thousand routes on the internet, that's quite a lot of filtering. And also you're taking your decentralized routing and all of the authority is now going back to a single database. What happens when it breaks? It's being worked on anyway, so hopefully that will make the internet a better place and stop this. But as of today, this is still quite a serious problem with BGP. So hopefully that's being fixed. If you look, there's many websites here. robtex.com is especially a useful site for analyzing and looking into other people's routing, seeing what paths are there, who's peering with whom. bgp.he.net is another one. Similar tools, but it allows you to sort of say, you can look, what is my ISP, what are my paths, how are these peered, where are my packets going? This can give you some idea of looking into BGP and seeing what's there. There's also many networks are operating looking glasses. So you can go, for instance, I used to work for this company, Allstream. This is one of their route servers. You can telnet into it, and it's a Cisco device, so show IP BGP, and you can take a look and see from the perspective of that network, what is their view of the internet? Because as all the peerings are all over the place, very complicated, things going here and there. One network's view of the internet will be slightly different than the next and the next, and so these things give you a good idea into what's actually happening there. And also at lookingglass.org, there's a huge, huge list of route servers by network, by country, wherever. If you're having a problem reaching Australia, maybe you can find a route server in Australia and say, what does the internet look like from here? That's it. This was a very hastily arranged presentation, like I said, so I've skimmed over the surface very quickly. There are many, many topics that I've not covered, but I imagine everyone is also perhaps getting hungry, so if there are no questions or anything, of course, also feel free to find me. I'll be here until the end of the event. If you have any questions about BGP, there's a bit of a rumor circulating that I'm some type of BGP expert, which I would like to declare is completely false. I'm by no means an expert at this, but I have been working with it for quite some time and have quite a bit of knowledge about it. But yep.
So okay, I have a question. You got it before you had 3 routers. You had those 3 routers. So my understanding that R4 there does not need to be running BGP.
Not necessarily.
Internal versus the external.
Well, yeah. So it could be an internal BGP peer. It could just be a stubby router hanging off of there. In which case, it may get a default route of some sort through OSPF or ISIS or who knows. Again, this is an exceedingly simple diagram just sort of meant to show a very simple propagation. In reality, it's obviously quite a bit more complicated than this.
But I mean, in general, only the edge routers are BGP.
Typically, yes. In our network, we have 2 edge routers at the top, which are connecting to all of the peers, all of the transit links, all of such things. And then we go down one step further into the 6500s. We're running BGP down there because it allows us to aggregate all of these different routes coming in from the edge and bring in a consistent view into the center. So we happen to be running BGP there, but that's just our network, that's our implementation. Your mileage may vary, obviously. Any other questions at all? No? Okay.
Okay, I will be very fast because I obviously talk a lot on this, and I'm also very hungry. There was just one short thing about one project we were already doing, and some of you already know about it. So we deployed one solar node in Ljubljana. So it is a solar powered node, which is why it may be different because we connected router to the regulator itself. So we are able to capture all data of performance of this fast internet, the solar panel, and we are collecting this for 2 years now already. And what's good also is that this data is also visible. So if we go to our node database, we have there solar. We have there a node, and this data is then available on in graph form here. Very fast, very fast. Okay, so the idea is that maybe in this graph you can see how the weather influences the solar and so on, because it is like really long-term experience. But the internet is just not working anymore. So the next thing is just a few seconds to explain our experience. So our experience is that you have to be careful with the accumulator not left going to the low end of the voltage during the winter, because it freezes and then it never fills up in the spring. So you have to preset that it shut down itself and protect itself before this happens. And the other thing is that we are living in the area where during the summer there is too much power, and during the winter there is never enough solar power. So whatever you do during the winter, you have periods of downtimes. For example, currently the node is still up, but it will be probably in a few hours down. And in the summer it is like it has just okay, here it is. So this is the page, and so this is like, so yeah, so at 12 o'clock it turned on, and now it is still up. And this red line is the voltage on the solar panel, and the blue line is the battery voltage. You see here, charge. So in this time there was some filling, but otherwise not. And this is for the last day. You can also check for the last week, so you can see that there are interruptions. So we have bad weather, as similar as here. Currently, Mount also. So yeah, so there are some periods of good weather, and then and if you go even before, so this is here we fix the battery. At the top before this winter we left it on and drained it fully, and then we fix it, and then it was nice May, June, August. It was really nice. Then in September the rainy days began, so it starts slowly deteriorating, and then in October you have first gap, and then you have from time to time other gaps, and then it turns on when there is enough, and so on. So from this, and this is 1 Linksys and 50 watts. So this is quite big solar panel. And as you see, it is not possible. It cannot, still cannot make it work 24 hours per day in the whole year. So it is really really bad. So, but during the summer it is without problems. So this is really, we live in quite high. So Africa probably they don't have this problem, but here, so during the winter. So my conclusion is that in this height of the Earth, the solar panel is not a viable solution to for nodes to operate 24 hours per day. But it does work in summer and it does work when it's sun, also during the winter. Okay, so if you have any more questions about that, or data set you want or something, you can, yeah?
How do you measure the voltage?
So we have there was, so this is a proprietary regulator which has a serial output, and you can just access it, and we made an open source. But okay, it is proprietary regulator, but it's all closed hardware. But I sent them a request for specification for this protocol that I'm writing open source driver, and they just send me and say, please just send me link to your driver when you finish and so on. So they're really this is. This is reselling by Focus in EU, but it is one Australian firm originally, and they're really great. So they just sent me a specification. I wrote it. I also had some problems with it because it was like badly some errors in documentation, and they sent me corrections and so on. So really good company. So I got the specification. I got the drivers.
How much does it cost?
Yeah, so it is costly. So the whole thing was 1,000 euros, solar panels 800, and this is I think 200 euros is the regulator because it is for bigger nodes. I don't know if it is. Yeah. So yeah, it is oversized, but we got it donated, so it was better. But yeah, it would be much better if we would have some open hardware dedicated for this. And this is our second project we'll be probably making open hardware for that.
What kind of solar panel you're using actually?
Kind of in the sense of size or?
No, the model.
I don't know which one this I think is some that crystal something. I don't know. Yeah. And the idea what we got is that these are still the Linksys is quite hungry for energy. So maybe the good way to solve this problem with energy would be that we would have take old smartphones, which are Android and so on, flash it with OpenWRT and put it on the solar panel because they are really made for low power consumption. They have USB plug-in, and you can fill it already, and they have also internal battery already, so you don't need anything. We should just find a way how to attach a bigger antenna to it, and this is it. Yeah. So this is my proposal for solar nodes: is Android phone, solar panel, and this. And do you have something to show?
Last question.
Just to show. Albert is here. He brought 10 of these solar panels. They were used for a park meter. In supposed to be used.
And you stole it or no?
No, he stole it.
Everything is legal.
What? So tomorrow we will have 5 nodes of the network using 2 of this for one Fonera, plus 4 1.5 batteries that will be recharged by the solar panel, and they can power the Fonera for 3 hours from our test. So we'll see how long we can have them on the network running the mesh protocol.